Now it is time to finally start coding. Generally, we code here in the script section, because here tools like CodeCheck and autocompletion are implemented by RStudio. Of course, you could do it the old-fashioned way and insert the code directly in the console below here, but that does not really make sense. I have a new script called basics, which contains some commands I want to go through. Generally, you could use R as a giant calculator. If we simply type, for example, 4 plus 4 plus 5, and we're gonna send it via run, we get the correct output down here, which is, of course, 13. Note that whenever you want to run code, the mouse needs to be in that specific line. If you want to run several lines, like in a function, you can either mark the whole block of code and run it, or you can put the mouse in the first line of the block and you can run each line one by one right till the end. Note that the space between the numbers does not matter. R is not sensitive to that. If I add several spaces over here, I would get the exact same result. Generally, we have the basic arithmetic operators like plus, minus, divided, the star for times, and the caret for power. Let's type a command with a specific order of operation. Let's say we want the third power of 5 minus 3. With the standard round brackets, we tell R to at first calculate this part, and the caret indicates the power of 3 of this calculation. This would mean 5 minus 3, which is 2, and then subsequently 2 would be multiplied 3 times by itself, which is 8. Next, we are going to create objects. This is very important to understand because nearly anything you do in R will be done via different objects. An object is basically an alias for data you want to bind together. An object can be a whole dataset you load into R. It can be a result of a calculation, or it can be a part of a dataset with specific traits. It is also important to note that an object can have different properties. Therefore, we have different object classes in R. Those of you new to programming will hear this for the first time, but it is crucial to understand. The object class you select for your data will determine what you can do and cannot do with your dataset. The classic object class in R is the data frame. It is similar to an Excel sheet with columns for variables and rows for observations. Most of the functions in R work with data frames. Therefore, it is the single most important object class for you to understand. In this example, we will now start with a very simple object, probably the simplest object class in R, the vector. A vector is simply a collection of values of the same class. An example would be stock price data for a company. If you store the daily average price of Amazon stocks over 20 business days, and you put them in one Excel column, you have a vector. If you add the date as a separate dimension, you would get a time series class or TS in R. The price in this case will be a number with decimals, therefore it is a numeric vector and not an integer vector. Alright, so let's create our first object. We're gonna call it X. X has 3 values here, therefore it has the length 3. Those are just the numbers 4, 5 and 6. If we run this example, we add the object to our environment. Here we learn that this is a numeric vector, and indeed it is also confirmed that it has 3 values in it. You assign values to an object by either using an arrow, like you do here, or you can use the equal sign. The arrow can point to both directions, As long as the object name is directed towards, you are fine. As you can see with the object y, it works just fine. At this point, you might ask yourself what this lowercase c means at the beginning of the values. Well, this is an extremely important feature which stands for concatenate. It tells R that all the values within the round brackets belong together. They are one vector. This little c can even be used within functions when you want to provide several inputs for one argument. Those arrows are the preferred way for assignments. You can do the exact same thing in a more complicated way. You can use the assign function. If you are using this function, you at first need to state the name of the object. This needs to be done under quotations, since we are dealing with a character. And after the comma, we can indicate the values we want to put in our vector. Here we need the concatenate c within a function. We are telling the function assign that those three values in brackets belong together and should be used as one argument. After we run this line, we can confirm that it worked. We have a new output in the environment over here, which exactly matches our input. We have the object name, the class, and even the values displayed here. So this is now our new or updated object X. As you might have noted, down here in the console, there is not much action going on, at least not visibly. We can see that there was a calculation sent to the console, but we do not get the output. This is because in a line of our code, we only tell R that we want a new object, called X in this case, but we do not tell R that we also want to directly see this output. To do this, we have to type the object name in a new line and of course run it. This is quite important to realize because when you run code, the calculations might work just fine, but you do not get to see the results without typing the name of the object. By the way, you can use the semicolon and state the name of the object once more like you do here. A semicolon is like putting code in a new line, and you will get the output right away just by executing this one line of code. By the way, and this is extremely important, R is case sensitive. If you name a vector lowercase y, you need to call lowercase y in order to print it. R would not recognize uppercase y in this case, so you would get an error message. Managing your objects is not only possible in the environment. You can of course also code this. For example, if we want to see which objects we already have created in our session, we can run ls on empty brackets or objects on empty brackets. This basically gives you a list of occupied object names, if you will. So in this case, we already have the objects x and y created in this R instance. Of course, if you assign a new vector to the name x, like we did several times in this session, the old vector x will be overwritten and the data is lost. To remove an object from the environment, we can run rm and then the name of this object. Now we just deleted x from our environment. Note that whenever you want to refer to a name, you have to use those quotes. They tell R that this should be considered a character. So now that we have all those vectors created and we know how to manage our objects, let's get a step further. Let's work with those objects. We know that we have the object y already created, which is this vector over here. In this example, we now want to create the object x, which should be a vector of 2 times y and a 5 in the middle. The whole thing should have double the length of y plus an extra digit. Let's run the next line and let's also see what we would get in this output. And indeed we have a repetition of y with a 5 in the middle. So that is how you can use an object within an object. And that also explains quite well the power of those objects. Just by typing y, you have incorporated 3 values. We can now use all sorts of functions on our new object x. For example, we can sum up all the values. The command for that would be sum and then in round brackets x. So this would be 175.4 in this case. Again, it is really easy to do those kinds of calculations when you have all your data packed in this single letter x. It also leaves nearly no space for typos. Alternatively, we can also get the square root of x. In this case, we get another vector of the same length. For each single value of the vector, we now get the square root. By the way, when you have a long vector and you want to see which value hides on position, say 1, you have to use the box brackets. Box brackets always indicate the index position. In this case, it would be the number which is the first value of the vector x, as we can also see here, so the output is the expected value of 4. In the next example, we will perform a test on our vector x. We want to know if the values are smaller than 5 or not. That means we would expect a vector of the same length of x with the Boolean values true or false, since a logical test can only be true or false. This time we will store the results directly in a new object, which we will call new object. I will use the semicolon trick here to get the output right away in the same line. As we can see, we have the positions 1 and 5 that are smaller than 5. They are denoted as true. The other do not fulfill that criteria, therefore we have a false. We can double check the results with the original vector x. And this indeed confirms that those positions 1 and 5 are smaller than 5. Now I want to explain to you when to use which types of brackets. Basically we have 3 types in R: round, box and curled brackets. The round brackets are the standard form. You will most of the time use this type of brackets. Whenever you want to indicate that the given portion of values belong together, you have to use this type of brackets. Also, the predefined functions in R use those types of brackets. The box brackets, on the other hand, are mainly used for data filtering purposes. They indicate the index position within an object. Depending on the object class, you can specify the simple index position in a vector, which has only one dimension. You can specify row and column index in a data frame to extract a value from a data frame. Generally, for each dimension of your object, you have opportunity to specify an index ID. And at last, we also have the curled brackets, which are mainly used when you write your own functions. The second part of a self-coded function needs to be specified in those curly brackets.